All right, I think we're going to go ahead and get started with today's webcast. I see quite a few people still coming on, so I will talk slow on the intro so everyone can listen to Tim. I want to thank you for taking the time to log on and hear our June Oxygen Blast presentation presented by Tim Starr. We definitely appreciate that. My name is Pat Shaber. I'll be working with Tim on the presentation. As our customer base has grown to become much more global, we've used these oxygen blasts as a way to stay in touch. We've increased the frequency and the topic ranges, so please check out our website. There's an area of free, where you can see all of our free classes. These are there, and then also we'll be talking about at the end about some upcoming classes as well. Before Tim jumps into Agile Design, I want to take a minute just to introduce you to Intertek. Our firm has been around since 1991 and has grown to be the largest software and IT training and consulting firm in the state of Minnesota. And along with that, we've expanded quite a bit in the last 5 to 10 years, both nationally and globally. We're the recipients of 35, close to 35, almost 40 awards now for growth and top workplace best practices. I like to tell people that, put simply, our employees love to work here and we produce results. But with that, our focus remains on our customers and their satisfaction with our work. As you can see on the slide there, we are quite proud of our satisfaction ratings. And to that end, we've developed a model that we believe works. It's based on instructors who consult and consultants who teach. We've maintained pretty stringent hiring practices since beginning. That's helped us build a staff of very highly experienced professionals that not only empower some of the great Fortune 500 clients that we have with software innovation, but we also mentor, teach, and train those same software professionals. We feel it's a pretty good recipe for our growth and also for our customers' growth. Along with the presentation, today you can see a little bit about our training and consulting practices there. And along our presentation, we'll be on Twitter with an Oxygen Blast hashtag, so hashtag Oxygen Blast, all one word. I'll be facilitating a discussion out there should you be on Twitter and want to join. We have a Q&A panel where you can ask questions, and we do have quite a few people on the call, so I don't know that we'll be able to get to everyone's questions, but my contact information will be at the end, and if you don't get your question answered, please feel free to contact me. I'll make sure that you get an answer. With that, I want to turn the presentation over to Tim, and I'll let him get started.
Thanks, Pat. So thanks everyone for joining, and just a quick note, we are recording this session, so if for some reason you have to drop off in the middle, the session will be available. I believe it's out on YouTube, but contact Pat or myself if you have some questions. And in addition to pinging Patrick at the end of the session, if you don't have a question that's answered, or if you don't want to ask it in front of everybody, feel free to directly email me at tstar@intertek.com. Also, just a quick note, I write about a half a dozen or so blogs a year, and you can find those out on www.intertek.com/blog. And so a little bit about me. I'm a principal consultant / .NET architect here at Intertek. I've been here for about 6 years. I spend maybe 10% of my time also doing some training here, by and large around Visual Studio, unit testing, test manager, that kind of thing, and also some design pattern courses. I've been writing software for over 20 years now, just had to change the slide, so I'm getting up there in age. And so that is to say, not that I know everything, but I've made a lot of mistakes in the past, and I've learned from those mistakes, and I continue to learn from those mistakes. So hopefully I can explain some things in a way that makes sense to you and help you avoid making the same mistakes that I've made. The rest of these are acronyms we don't really need to worry about. And so today I want to talk about solid design principles. So if you've heard that phrase, what we're talking about is a set of principles that have been around since probably some of them have their roots in the 80s when modular programming was popular and before object-oriented programming came to be. And I'll warn you right now that it's a very soft topic and open to interpretation. So today I'm certainly going to do my best to give you my interpretation and the way I try and think about these principles. And so we're going to go through each of the 5 principles independently, and then we're going to just break into Visual Studio and look at some example violations and ways we can do things in a way that I think is better. So what's the motivation for this? And this is, and to give credit where credit is due, the majority of this topic leans heavily on my readings and understandings of Robert Martin, or otherwise known as Uncle Bob. Most folks, I imagine, have heard of him. If you go out into Wikipedia or you go to any of his blogs, he'll freely give credit to some of the folks that were thinking about this well before him. So just to get the credits out of the way, Uncle Bob Martin is really my mentor, if you will, who I don't know personally, but from a reading standpoint. So anyways, the motivation is we want the ability to develop software quickly in the face of rapidly changing requirements. So Uncle Bob basically said, okay, things change all the time. Let's figure out a way to design stuff so that we can just deal with it. So it's not such a big deal. We want to be more flexible, maintainable. And I think an important thing to think about here too is testability too, because some of these principles really lend themselves to being able to do a better job of testing in isolation and quickly. So the first principle is the single responsibility principle. And I'm going to do a little bit of reading of slides, which I don't normally do. And that's really just to try and keep the precise definition. And then I'll talk about more in general what I think it means to me. So if you go to Wikipedia and you look up the single responsibility principle, you're going to see 2 definitions. The original is kind of radical. It's every class should have a, I'm sorry, I'm on the wrong side. Every class should have a single responsibility, and that responsibility should be entirely encapsulated by the class. All of its services should be narrowly aligned with the responsibility. Okay, so not so radical. I've even heard the single responsibility described as a class should have one and only one reason to live. And all of that makes pretty good sense. But Martin thought about this, and he's got a really interesting definition for this principle. And so his definition is that a responsibility, Martin defines a responsibility as a reason to change, and concluded that a class or module should have one and only one reason to change. So I thought that was pretty interesting. This is probably the hardest principle to follow. It's got the softest rules, and when we look at some code, I'll talk about some of why I think things should be organized the way I have them. And so the benefits of following this are that highly cohesive classes, and cohesion is a measure of how strongly related each piece of functionality expressed by code is to each other. So highly cohesive classes are easier to maintain. So if you open up a class and it's got code that's all kind of related to each other, it's a lot easier to figure out what's going on than if you've got a whole bunch of different concepts and concerns spread out throughout the class. But also, in my opinion, simplifies testing. To me, it's a lot easier to test a class, to test a handful of classes with one concern each than it is to test one class with a whole bunch of if-then-else structures where you're trying to work your way through all the paths of the code. One of the drawbacks is certainly when you look at a project and you see more classes, it tends to at least be more complex to navigate and have an understanding of the overall structure of an assembly. And code smells. So what do I mean by that? This is when you're kind of sitting there and you're writing out code and you kind of get this sinking feeling in your gut that, you know what, this doesn't feel right. I'm doing something wrong. This is what I'm talking about as a code smell. So anytime you're dealing with a class with maybe hundreds, certainly thousands of lines of code, you're probably violating the single responsibility principle. Or also if you're looking at a class with many unrelated or very loosely related methods. Open-close principle. So this one states that software entities, and that's classes, modules, functions, should be open for extension but closed for modification. And this is the one that has some pretty radical roots. A gentleman named Bertrand Meyer advocated that once code was done, so in other words, once you got things up and working, it could only be revisited for fixing bugs, and that any changes to the behavior had to be done through inheritance. And personally, I'm not a huge fan of inheritance. I don't like deep inheritance structures, so when I hear that, I shudder a little bit. I don't question his intelligence, and I don't claim to be smarter than him, but that scares me a little bit. Later, Robert Martin, after contemplating this topic, he kind of suggested that this could be accomplished via polymorphism and abstraction. I got to thinking about what that meant, and so the original definition from Bertrand Meyer to me was more about how do we write and maintain our inheritance structures. But what I get out of Uncle Bob's description of the principle is that this is more about how do clients consume servers. And by that, I just mean the consuming code where a server is some other class that a client is using. Okay, so I think of this principle more about how do we write our clients in such a way that they can be extended without me going into the source code and having to change things. And so the benefits of this is working code, client side, working code stays working, and changes are still achieved via new code, but the new code in this case is more of what I'm calling the service code. Okay, again, the drawbacks, whether or not it does tend to add a little bit of complexity, but I think that's more of a short-term thing, and that's going to be a common theme with all of these principles. I think once you wrap your mind around the techniques and you get used to using them, it becomes so natural that it's actually hard not to use them. And so what are some of the code smells? How do you know if you're violating this principle? That's when you've got a bunch of switch logic. Maybe you're doing a switch on what the type of a class is. If I'm this derived class type, do that. If I'm this derived type, do that. Big if-then-else structures. If you've got server or service-specific code within your client, in other words, you're coding in a way that you're aware of which service you're using, that might be a violation. And that should make a lot of sense, hopefully, when I show you my example. Liskov Substitution Principle. This principle states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. This one, too, is one of the principles I struggle with a little bit, but I really dove into it pretty deep over the last several months and starting to feel like I've got a better feeling for what this principle really means. And in a way, how following this principle lends itself to helping clients to write modules that are more open and closed, so open for extension, closed to change. So in this case, now this really is more about inheritance and the rules we follow when we're writing derived classes. There's kind of two pieces to it. We want to follow the rules structurally. We don't want to be changing types and that sort of thing. And then the softer rule here is that we also need to follow the reasonable intention of what an abstract class is. And that's where it gets a lot tougher to do. And I think I found some good examples to demonstrate how very subtle violations of this can cause some larger problems in clients. In other words, cause clients to break just by changing things that they're dependent on. And so the benefits here are following these principles makes your derived classes or your classes providing services more reusable, makes the maintaining code that calls into those classes easier, and it certainly makes the client classes more robust. Frankly, I can't think of any drawbacks at all other than you might have to do a little bit more code because you quickly realize that rather than saying, you know what, my derived class is really close to my abstract class, so I'm gonna use some of those services, and then I'm gonna fudge a little bit just to kind of get to market faster. So in a way, you're probably going to end up with a little more code if you apply this principle correctly. And so what are some of the code smells here? Code smells here are definitely method hiding. So using a new, I'll show an example of that actually. Let's just wait till we get into code on method hiding. Throwing a not implemented exception. So if a base class, if an abstract class has a couple of abstract methods and you implement those, but your implementation is just throwing an error, you're probably violating this. Covariance. Covariance is really about converting less derived types to more derived types, like converting from an object to a string. Another word I may use a little bit in the talk is contravariance, and that's kind of the reverse of that, and that's treating more derived types, like a string, as a less derived type, like an object. Okay, so anytime, just notice the line of code. I've got an object array, and I'm setting it equal to a new string array. Now, it's certainly legal, and it's going to compile, and everything's going to be great, but if somebody's expecting an object in array and tries to assign an object to that, they're going to get an exception, and that's going to cause problems. I've got an example of that as well. And then the soft rule is code smell. Derived class violates a reasonable assumption about the base class, and that's really where you go back into the slide here that's got the joke, if you will. If it looks like a duck and quacks like a duck but needs batteries, you probably have the wrong abstraction. So the notion there is that a duck-based class probably has a heart and things in common with other living creatures, and even though a electronic duck seems like a duck, it's not really a duck within any reasonable expectation of a duck-based class. Okay, so the next principle is the Interface Segregation Principle. This principle states that many client-specific interfaces are better than one general-purpose interface. This, to me, is the single responsibility principle applied to abstractions, so interfaces or even abstract classes. And the benefits here are less code, in that if I want to implement an interface that only has 3 methods, that's going to be a lot easier for me to implement than if I've got this humongous interface that's implementing 30 methods, for example. So I can end up less code and still interact with the items that want the services of that interface. I also lower the impact of testing with change, and in that I mean that even though interfaces are supposed to be set in stone, they change every once in a while. And so by having many smaller interfaces, clients are what end up binding themselves to these interfaces. And so the clients have sort of a smaller surface area of things that are going to make them change if they're able to bind themselves to these smaller interfaces. Drawbacks, it does, again, it's just from a manageability standpoint, when you look at a project with dozens of interfaces, it can get a little unwieldy to look around and navigate through and that sort of thing. But I don't think it adds a ton of complexity. And you can also tend to overdo it. And in that, I mean, okay, so if having a bunch of interfaces is better than having one fat interface, why not just have all interfaces implement one method? And in there, things are just going to get too watered down too, and you're not going to have things, you're not really going to be able to take advantage of polymorphism and sort of the intent of classes that logically implement a handful of interfaces. is easy. And then, so code smells, these are along the same lines as the single responsibility principle, in that if you've got an interface defined and you're hitting page down, you're probably violating this principle. And then the other code smell too is if you've got interfaces with unrelated concerns. The final principle I want to talk about is the Dependency Inversion Principle. And this principle states that we should depend on abstractions and do not depend on concretions. And a little bit tough to get your head around at first until you see it in action. And so I'm going to rely on the demonstration to explain that a little bit better. And so the benefits here are things tend to be more maintainable and resilient to change. They're definitely more testable. Using the Dependency Inversion Principle is what allows us, if we design a system in a way, this is the thing that allows us to, for example, exercise the code within the business layer without hitting a database directly. So my tests are going to be a lot faster. I'm going to be able to run them over and over again without worrying about any constraint violations and that sort of thing. So this is one of those principles I highly encourage you to wrap your head around, start playing around with it, and start using it. And as far as the drawback here too, it does tend to add complexity, and you can't overdo it, though where the bar is for being overdone is certainly up to debate. I'll kind of mention where the bar is for me at the end of the presentation if we've got some time. And again, that's just a soft rule I have. And the code smells, oddly, are when you're newing things up, when you're creating concrete classes within your client code. And so when you think about that, and this is, again, a little bit into the overdoing it. So when I'm thinking about that, what I try and do is I allow for things to be created, objects to be instantiated from within the framework. So I'm not going to worry about seeing, give me a new date time object, for example. In my mind, that's a Microsoft object. They're responsible for testing it, keeping that thing working. Yes, it's a hard dependency that I'm allowing in my class, but in my opinion, that's easier than abstracting the notion of a date-time object, wrapping it in something with an interface and having that dependency passed in to a client via constructor injection or via method injection, and I'll show examples of those. So in my opinion, that would be overdoing it when you say there shall be absolutely no object instantiation within a class. But what I don't want to see is within the business layer, for example, I don't want to see instantiating a data layer. Okay. All right, so let's pop into the demonstration then. So I'm going to flip into Visual Studio, and let's take these principles in order. So the first principle, we're going to talk about the single responsibility principle. And I'm going to talk about this in terms of a class has one and only one reason to change. And so if we look at a violation of the single responsibility principle, let me increase the size a little bit there, clean up that window, more real estate. That's better. Okay, so if we talk about the single responsibility principle in terms of I want a class to have one and only one reason to change. We take a look at, most of these examples too are just going to be pretty much dead simple, given real estate and presentations and these kind of things. Visual Studio doesn't present too well, so just forgive me. There's a lot of liberties with code and a lot of comments explaining what it is conceptually that I'm trying to demonstrate here. But let's look at a simple class here. This is an order class, and it's got a couple of properties, order ID and customer ID. And it's got a method, and this method, process order, is responsible for creating something or having something built. And the rules around creating that is the first thing I need to do is notify a manufacturer, and then I need to notify shipping to be ready for some sort of a shipment, and then I need to say send a confirmation to my customer. And then down here, I've got some little stubs here demonstrating where presumably the code could live. And so down here, I've got send confirmation, send an email to a customer, notify shipping. That's just sending some kind of an electronic request to UPS, for example. Notify manufacturing. Maybe I need to generate an EDI document and FTP it to some mainframe or something like that. Okay, so conceptually, that's what I'm trying to do. And we say, okay, what kind of things can change that would require me to go revisit this class and change it? So what are my reasons for change? Well, if my manufacturing order flow changes, I'd have to come in here certainly and revisit it. If my message type that I'm sending to manufacturing changes, maybe we've got a new manufacturer, but we've grown so much and I need help and we've got a new manufacturer and they want XML. Well, I'm certainly going to have to go in and change this here. Maybe we negotiated a better price with U.S. Postal Service this year and I want to change from UPS to USPS. That'd be a reason to change. And maybe I want to get with the times and rather than sending an email, I want to send a text message. So that's really a lot of reasons to change. Now, you could make an argument, a very good argument, and say, Tim, I've been manufacturing this thing the same way for 10 years. It hasn't been a problem. And I'd say, then by all means, code your class this way. That's great. Go ahead and do it. But if that's not the case, and you suspect you're going to see changes in any of these things, maybe a better structure. Notice this is just dead simple from a structural standpoint, one class. Well, notice what we might end up doing. And probably I'll leave the interfaces out of the discussion a little bit for now, because that's really starting to bring another principle into play. But now, rather than doing that, what I've done is saying, okay, rather than having the order responsible for all those things, I'm going to make the order responsible just for the order flow. And I'm going to delegate responsibility of sending the manufacturing, shipping, or customer message to other things. So these are the services I was talking about earlier. So if we look in the customer message, the only thing this guy is responsible is gathering a little bit of information and sending the message. And the only thing manufacturing message is responsible for, again, gather some information and do the actual sending of the message, format and send the message. Shipping, same thing, gather enough information so that maybe I can call a web request to some sort of a web service that UPS runs. So these are all simple, straightforward classes. If I need to change shipping, I know that I come right into the shipping message class, and if I need to change manufacturing, and so on and so forth. So to me, this is a nice intuitive way of breaking down responsibilities around change rather than around maybe what feels right or what might be logical. Okay, so there's 4 different processes. All these processes may change or formats, and this feels better to me. Okay, the next thing I want to demonstrate is the open-close principle. Okay, so in this, let's see, the open-close principle, remember, means that software entities, whether that's classes, modules, or functions, should be open for extension but closed for modification. Okay, so in this case, what I've done is I've kind of written a class in the shape of a database service. And so here, this DB service class supports creating, updating, selecting, or deleting. So it looks like a common partial interface of maybe a data layer. And I've got a second persistent type container, and this one uses Azure Table Service. So this is a non-relational database storage mechanism. And for the sake of argument, let's assume that this storage mechanism does not support row updates. Okay, that's not true, but let's assume it doesn't support row updates. So the only stuff I can implement here is create, select, and delete. Okay, these guys are probably in different assemblies than this thing, so don't worry too much about sort of the assembly breakdown of the way I've put this together. It becomes very important for the Dependency Inversion Principle, less so important for here, though in reality you're probably going to see all of these things be in a different assembly. So if we look at some client code which might violate the open-close principle, what I've got here is a client that's responsible for saving a list of things, a list of objects, just persist some stuff. And so what I've done here is I've exposed a save interface. It accepts a list. And I've gone through and said for each item, figure out the type of item that it is. So if the item is a type, Azure Table Storage, then go to my Azure specific save code. And within here, what I've done is I've just said, okay, so if the row exists already, then delete it and create a new one. Otherwise, I might even have a bug. Yeah, I got a bug here. So if the row exists, delete it, I'm sorry, and then create a new one. But for the database, this guy supports updates. So then what I say is if the row exists, call the update method, update it. Otherwise, we'll create a new one. Okay, so the violations that I have here is that I've made my function type aware. So if you've got some sort of an Amazon Web Service concrete class added to the mix over here and it's passed in over here, we've got a problem. You cannot support that Amazon Web Service class without coming in and changing this flow here. The other issue is that I've got I've got implementation aware code within my client here, when really this kind of implementation detail probably belongs in the services. Okay, so a better implementation of this might be a structure like this. So the first thing that I want to do is I want to define some sort of an abstraction. And in this case, I call the abstraction upsertable. An upsert, that's a real thing. I didn't just make that up. It generally means in the industry, insert or update. I don't care if I'm creating it. I don't care if I'm updating it. Do one or the other. I don't need to know about it. Okay, so I've defined this upsertable interface. And things that do upserts tend to be able to do selects, creates, and the upsert. And I've said Azure Table Storage. I'm going to implement my upsert. So he does create, he does upsert, select. You can even do delete and things that aren't necessarily on the upsert. That's fine. But here my Azure Table Service at a minimum is going to implement the iUpsertable interface. Now in my DB service, I've also implemented upsertable among other things. So that needed to implement create, didn't have to do an update. I did have to do a select, delete didn't matter, and then an upsert. And within this upsert is where I do the actual specific logic of how a DB service manages the update. So within here, I'm doing my select, and then returning the count that I update, so on and so forth. So I'm doing if it exists, update it, otherwise create it. And similarly, my Azure Table Storage, I'm implementing the details here as well, right? So here, if it exists, delete it, then create, otherwise just create it. Okay, and then what that allows me to do now is write my client code in such a way that I can accept any sort of upsertable things. So anything that implements upsertable, I can accept that in my list without coming in here and changing this thing. So that's really powerful. If these things are in different assemblies, and presumably there's some higher level class that's using the services of the client. So some higher level class is assembling a list of things that it wants to coordinate a save to. I don't have to go in here and change it if you want to support Amazon Table Storage or something like that, as long as the Amazon Table Service implements iUpsertable. So this can be really powerful, and this is kind of how I've grown to think of the open-close principle. Think about it in terms of clients. And the keys, some of the keys there really are get rid of type awareness, get rid of type-specific logic, and make use of generics and interfaces as much as you can on your function footprints. It makes what this code can consume a lot more robust. All right, the next principle, probably going to be our longest principle to go through. So I've got kind of a laundry list of violations. The next principle is the Liskov Substitution Principle. And again, that states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. So really now, when I think about this, I don't think in terms of an is-a relationship. That's kind of the standard where a mallard is a duck or a bluebill is a duck. I no longer think in terms of is-a. I think it's more appropriate to think in terms of substitutability, right? So a mallard has to be substitutable for a duck. A bluebill has to be substitutable for a duck. Is a toy duck substitutable for a duck? Not necessarily. So I kind of changed my thinking around from an is-a relationship. It's no longer good enough to be an is-a, and I have to think in terms of, am I substitutable? So let's close a bunch of these classes here. And let's open my example-based class. So pretty simple here. I've got an abstract class called example base. I've got a couple abstract methods that every derived class must implement. I've got a couple of virtual methods here that classes may or may not implement if they choose. I've specifically added some generics and typing within this class just to demonstrate some things. So we'll kind of come back to this every once in a while throughout the demonstration here. So first of all, the compiler is going to do a lot of things to save us from violating this principle. So there's kind of a whole list of things. Let's see if we got enough real estate for this. Yeah, that's not too bad. So let's kind of look at a laundry list of things that won't compile, that seem to make sense but just aren't allowed. So over here on the right is my derived class, right? I'm deriving from example base. And I'm saying I want to override the SumList method right here. And the key difference here is the abstract method says consumers expect to get a generic list of type int. And I'm over here saying, nope, I want to provide back a generic list of type object. But if I try and compile this, it's not going to work, okay? And then the other example I want to demonstrate here, where the compiler saves us, this is similar, and this is the do work method that says I expect a generic list of type int in my base class, but my derived, derived class, this should be object. Yep, the derived class wants to accept something of type object, and that's also going to throw a compiler error. And then one more little subtle violation here that the compiler is going to save us from is, again, I briefly saw a message pop up. So if you're privately chatting me, the better thing to do would be to use the Q&A panel, and then some of the folks helping me run the oxygen blast can interrupt with a question. And then just another kind of a subtle violation here is if we try and return a list of objects, so a list of less specific types in place of a list of more specific types, the compiler is going to save us from all of these things. So good job to the compiler on saving us from a lot of these violations of the principle. Let's comment that out, make sure we're still building.
Tim, while you have a pause,
yeah.
In the Q&A panel is a question from Gregory. Can you see that?
If I pull it up, I can. All right, is there some reason you're using a list type versus an ILS? No, not at all. Pretty good call out one. So why not use an abstraction rather than the list? There's no reason other than just throwing some code together, to be honest. So no, I wouldn't get too hung up on exact types. I'm really trying to demonstrate, trying to subtly play around with types in ways that seem like are okay, can be violations of this principle. So no, good question, and there's no good reason I'm doing that. All right, so those are things that the compiler is going to save us from. That's a great thing. Let's take a derived example, and let's look at some things that the compiler won't necessarily save us from. Okay, so first of all, I implemented the sum list just to get things to compile. There's no violation up there. Let's take a look at this guy. So this is one of those subtle violations that I was talking about. So here I'm overriding do work and saying I'm throwing a not implemented exception. And I've seen this kind of thing before. This is basically my derived example is saying I'm almost an example base. So I'm going to implement the same structure, but I don't really need to implement this method. Okay, so I'll just warn clients to call this, well, I didn't implement that one. And so the problem with that is working programs that expect this do work implementation, so if I'm going over a list of things that implement example base, and I call do work, which ought to be allowed, anytime I call do work on a derived example concretion of that, I'm going to get an exception. Okay, so that's just unexpected, and that should be considered a violation of the Liskov Substitution Principle. Okay, so this is really a spirit violation, not really a structural violation. The next thing I want to talk about too is, and this is sort of one of those spirit things too. Let's say that I've implemented over here a not null list. And the spirit of this guy is that no matter what you do, I'm not going to return you a null. I'll always return you an empty list maybe. So maybe that's the spirit of the thing. Well, this thing's virtual, so I can override it. And sure enough, I override it, I return a null. And so if a client or consuming code wrote code in a way that they never expected a null here, in other words, didn't check the return of this null list message for nulls, which makes for nice code if you don't have to check for nulls. I actually kind of like implementing methods that never return nulls. But any client code that calls into this thing and gets a null is probably going to throw an exception. Okay, so another one of those subtle violations that can cause quite a bit of problems. This one is a really non-obvious violation of the spirit here. And so this guy, I see we got 15 minutes, so I'm going to try and speed up just a little bit. But this guy, what did we do here? What we did here is we said, okay, rather than overriding another list, I'm going to create a new list. And so that's going to violate Liskov Substitution Principle, because if the calling code is using a reference to example base, when the another list method is called, it's going to get a list of 1, 2, 3 returned. But if you're referring to the derived example, when you call into this, we're going to get this list of 4, 5, 6. So we're calling completely different code here, which certainly can have unexpected consequences, but certainly is a demonstration that this derived example isn't substitutable for the base example, because when I call it via the derived, I'm executing actually different code. So that's really odd. And so just a quick example of that over here is, so in my example here, I'm instantiating an example base, new derived example, and I'm calling the bases another list. So this return should be 1, 2, 3. But when I call another list given the derived example, we're going to see that what I got back is a 4, 5, 6. So this is one of those odd odd consequences of method hiding, and why method hiding is probably a bad idea. And I'm not the person who wants to be looking for that bug. This one's a kind of a weird one. So to demonstrate that, go into my code. If I hover my base list, I get my 1, 2, 3 back. If I hover over my derived list by calling the derived type 4, 5, 6, so completely different code is being called depending which reference I have. So completely odd, complete violation of the LSP. Stop debugging. Let's see if we can get through the other. Good, only 2 examples. So covariance, this one, covariance for arrays, basically that this is something that the language enables for us. And the language enables implicit conversion of an array of a more derived type to an array of a less derived type. Okay, so here what I've got is a less derived type of example base, and I'm setting it equal to a more derived type of derived example here. And this compiles fine and it looks completely fine. Everything's great here, right? But is this a good idea? So if we look at some unit test code that calls into this, let's see what happens when so I'm creating a derived example. I'm returning the base array, right, an example base, and now I'm trying to add a different derived type to this array. So a more derived type example does derive from example base, so that ought to be completely allowed, right? So if that's allowed, this code should work just fine, and I should get an array with 5 elements in it. But if we take a look at what happens when I execute this code, so I get here just fine, and I'm going to step into this. And what's actually happening is it's saying, wait a minute, you're trying to put in a more derived example object into an array of type derived example, even though it was declared as an example base. So this is one of those other subtle areas where you're certainly going to have a violation of the LSP, and you're certainly going to have some weird results within your client code by messing around with the return type of the base class. And the final example, this is more of a by convention thing, and look what the language sort of allows. Where do we go? Here we go. Okay, this one we're saying, okay, so with a wink and a nod, I'm going to expose something called example base, but I'm really going to tell you just by convention that what I really want here is derived examples. And if you send me anything but a derived example, I'm going to try and stuff it into my array, and maybe I'm going to crash. So this is a strange and a more intentional violation, if you will. It's just kind of a bad programming practice. You would expect from a client standpoint to be able to pass anything that derives from example base into this array and things to work properly, when in reality the only thing that you can pass into here and have it work properly are those things that are of type derived example base. And hopefully that's an obvious enough example where we don't have to go through the unit test, because I'm getting a little low on time here. So let's jump into the ISP, the Interface Segregation Principle. And again, quickly, many client-specific interfaces are better than one general-purpose interface. And hopefully this one's pretty obvious to us. We'll go into my ISP violation folder. And what I've got here is an interface called the Swiss Army knife of interfaces. This interface implements things that are concerned with persistence. It implements or it defines the shape of things that are concerned with logging messages, and it defines the shape of things that have to do with manipulating strings. So it's just a mishmash of stuff. And so the bar for jack of all trades to be able to implement this interface here is he's got to implement the create, update, delete, select, so on and so forth. So he's got to fill out code for all of these methods to be able to implement this interface. And so the side effect of this is, from a client standpoint, my client, I've injected the dependency to the Jack of all trades class via constructor injection here. So something's instantiated, this Jack of all trades, passed it in via its interface. But what I've done as a client, the side effect is that I'm now bound to what this interface looks like. And if any one of these mostly unrelated things changes, I've got to revisit my client, go in and modify this. When in reality, all I wanted the darn interface for was to log a message. Okay, so hopefully that's pretty straightforward. And hopefully the solution to this is pretty obvious. And that's just to have an interface for each of the concerns. So over here, I've got a logger interface that's concerned with logging messages. Persistable interface, which is concerned with things like create, update, and deletes and fetches. My string manipulator interface is concerned with capitalization and reversing the phrase, things that require strings. And so by doing this, I did not require or forbid somebody from going in and implementing all these things. If the Jack of all trades wants to be the Jack of all trades, I can certainly go in and implement all three of these interfaces. I haven't changed the shape of this class at all. He can go do all those things if he wants. But I've lowered the bar for other things to be able to implement these interfacers. So now, if I'm a logger, I don't have to implement create, update, delete, and capitalize and all that other stuff. All I have to do is implement my log message with one overload. And from a client standpoint now, if I depend on this narrower iLogger interface, I've reduced the surface area or the reasons for me to change, right? So the only reason now that I need to change is if the logger changes. Okay, so hopefully that makes some sense. It is pretty intuitive. All right, the final principle, I'm going to be pressed to get her done in time, but I'll do my best. The final principle here is the Dependency Inversion Principle. And this is one of the more important ones, in my opinion. And the principle states that we need to depend upon abstractions and do not depend upon concretions. And so let's clean up the stuff. And let's go into a violation of this thing. And so quickly, what I've done is I've created this iLogger interface. The database logger implements iLogger in such a way that in this case, rather than a file, he's going to log things to a database, common practice. And the client now is going to use the services of that. Okay, and so remember I mentioned that code smells are newing up or instantiating objects. So what I've done basically conceptually in the client is I've said most of my methods or all of my methods might want to use the services of a logger. So at class creation time, via my constructor, I'm going to instantiate this logger and I'll let this log be used by any method that wants to use it. Looks good, not a lot of code. And so why is this a big deal? Well, it's a big deal because if I want to execute the client code on a wide variety of machines, I'm working with a team of developers, presumably the concrete database logger probably has a configuration file configured to point to a database. There's probably permissions involved in that this application needs to run as somebody with permissions or something like that. So there's some permission reasons not to want to do it. There's the speed. I need to cross-process and machine boundaries most likely to be able to call into that database, or I need to localize that database for this to work on a bunch of different machines. So there's a lot of reasons from a testability standpoint that when I'm executing unit tests against this, I don't want to actually use a logger. And by newing up the logger here, I'm tying myself to being stuck with using this, or if I want to use Microsoft Shim framework, that is a a potential solution. Don't want to go into it. It's a potential solution, but it's a little bit of smoke and mirrors. And while Microsoft basically allowed you to intercept the creation of database logic and return something else, it's basically saying, we're allowing this, but as soon as you can, refactor your code and just don't do this if you can, okay? Because things just run slower. So really a better implementation of this, and I've gone into a whole solution because I think it's a little more important when you think about the spirit of the principle to understand how assemblies are separated. Okay, so what I've done here is I've defined this interface assembly, and the only thing within this interface assembly is iLogger. And as far as things depending on this assembly, this is very low risk. I think there's a low chance for these footprints to change, and there's no implementation in code in here, or any implementation code that might be in here if I've got abstracts in here, would be very safe, very well tested, and very stable. Okay, so this is basically the interfaces assembly is assembly. I say, I don't care if you are dependent on it. It's a dependency I can live with. Okay, and then on top of that, what I've done is I've said, okay, so now I've got a business layer. And the business layer is the layer that tends to have the most code in it, and it tends to be the most important thing that you need to be able to execute unit tests against quickly and in a most isolated manner, right? So within my business layer, what I've said is I don't mind depending on my interface. It's a project dependency. Why am I not seeing it? Here we are. Interfaces. I don't mind depending on that, but I don't specifically want to depend on something providing the services or the implementation of this interface. Okay, so what I'm doing is I'm using constructor injection and saying, okay, I know I need to log things. I don't care if they go to files, memory, wherever they go. I know I need to log things. And I want whoever's calling me to pass that dependency or concretion into me. And all I care is that it implements the logger interface. And we can do that, in this case, if it makes sense for all the methods to do some logging, we can do this at the constructor level. And that's called constructor injection. Or if, pretend this isn't up here, if only a single method needs to be able to interact with something, we can certainly do a method injection here. So I've got my iLogger interface just on a method level here. I'm not doing anything to persist it in this case. I'm just simply using the log within this method. Okay, so by doing this, I've freed myself from being reliant on the concrete implementation, which in our case is over here in the storage layer, right? So over here, I've got a DB logger and I've got a file logger. And so now folks, if they want to log things to a database, go right ahead. If they want to trust that :/temp is there and every program executing it has permissions to write to that file, they can use something like a file logger. But when I'm doing unit tests, what I'm going to do is I'm going to create a test double. I'm going to create a different implementation that implements this iLogger, and I'm just going to create an in-memory database, if you will, and I'm going to use that for my unit testing. Right, so all I've done is created a name value collection. Log message puts a GUID in for the key, and it takes a combination of the message or message and call stack, if you call that overload, and it persists it into this array. So I'll admit that there is code in here, and this is open to a bug, meaning my test double could have a bug in it and report a false positive failure for the business layer, but I suggest that this is going to execute faster, and my dev team, my fellow developers, are going to be more willing to use unit tests written against this in-memory logger than they are going to be to, for example, set up a SQL server and build out the message log table and deal with permissions and all that good stuff. And so what that looks like from a testing standpoint is really simple. Rather than instantiating the database or a file logger, which would be done in, quote, real life or a real scenario, I'm going to instantiate this memory logger. I'm going to pass it into my client. My client code hasn't changed one bit, and I'm going to now execute code against an in-memory database, which is going to be a lot faster than the file system, the database, crossing process, whatever. Okay, so things are definitely a lot more robust. 2:02, we're a couple minutes after. There were a couple more points I wanted to get into, but I kind of considered those sugar. So I'm going to pause for a moment and see if any questions have come in. All right, barring none. Again, just a quick reminder, if you have a question for me, my email is tstar@intertech.com. Otherwise, you can, let me just do this really quickly before I let Patrick close things out. Yep.
Hey, Tim, we did have a question pop in from Alan. So if you open up your panel.
Sure.
And Alan, I think, well, Tim, I'll let you look at it.
So will this project be available for download? Yeah, so I can, well, Patrick?
I think we can find a way. The webinar will be available to watch for sure. Tim, how you bundle the project you're working on, I'm not quite sure. That's up to you.
Yeah, so how about we do this? This is dead simple. I'll clean the project, put it into a zip. Anybody interested in getting a hold of this, go ahead and email me. What I'll probably even do is maybe I can turn this into 5 short blog posts. So you can either hang tight and get the source code from the blog, or if you want it right away, just go ahead and email me and I can send you a zip that's probably going to be, I'm assuming, well under a meg.
Excellent. I think that's all the questions we have, Tim, right now.
Okay, so let me just quickly mention that this book here, Agile Principles, Patterns, and Practices, one of my favorite books, definitely a source of reference for all of these examples I put together. Also, Uncle Bob has got some, this I think is a 96 blog post if you want to look more historically at maybe some of the intentions of these principles. So I've got a link to that within the presentation. And also just out on Wikipedia, if you search for solid object-oriented design, you can get a lot of good information out there. And with that, Pat, I'll hand it over to you.
Thanks, Tim. Thank you, everyone that took the time again. We appreciate you joining us. Tim referenced our blog. It's intertech.com/blog, and a lot of Tim and a lot of the other senior and principal consultants here do all the posting, so a lot of great information out there. Our next Oxygen Blast, if you're subscribed to our email, we'll be sending out information on these, but we have one on July 30th coming up, and then one on August 13th. And some related training classes. I shortened the URL there. You give that a shot, or else just go to our website and search for .NET training. And we have a .NET design patterns coming up that talks about quite a bit of the things that Tim touched on here. So that's June 16th to the 18th. And again, if anyone has any questions, please feel free to contact me, and Tim might stuff for the next slide. I can be reached at pshaber@intertech.com. If you have any questions, comments, or feedback, we'd love to hear it. If you have ideas for other Oxygen classes that you'd like to see, feel free to contact me with that as well. And that's all I have. Tim, thank you. Everyone, I think we're going to log off unless there's any other questions.
All righty. Thanks, everyone.
Thank you.